actually going to put funny hats on all of us.
No. Oh yeah, this panel is augmented, so we're going to actually have things like going on above you. Right. Do we have another panel? Wait, that would be so cool. Just think of that.
Yeah, that's
Keep talking for 3 minutes. Okay, start the wave from the front.
Woo! Yeah! It actually started. I mean, my instructions are better than computing instructions. They actually listen.
I do that thing where I ask everybody to clap at me in my voice.
I just raise my hand and they all raise their hands. I don't know how it works, but it just happens.
All right, everyone, how's it going? Welcome to Tech in Motion. You can get a round of applause for our panel. Awesome. So we're going to introduce them in a moment. Before we do, I just have a quick questions for the audience. What did one support vector say to the other support vector? I feel so marginalized. I don't get it, but it was on Quora and it said it would make you guys better.
You guys all have to laugh
Wait,
now.
stand up, sorry. Okay, let's do an easier one. What do you call a blonde that dyes her hair brunette? Artificial intelligence. And on that note, I will pass this off to one of my favorite blondes, Samantha King, who is very intelligent. But before I do, thank you again for joining us. My name is Jamie. I work with Claire. We organize Tech in Motion, and we're so excited to see you guys here. Is it anyone's first event? Oh, I can't see anything. Well, welcome. Thank you so much for being with us. So without further ado, I'm going to hand it off. Stick around for Q&A after the panel, and then announcements about our after party and upcoming events. Thank you, guys.
Thanks, Jamie. Just for the record, I do dye my hair blonde, and I am not this color, but I am intelligent. And if you want to know more about the market, if you want tech career advice, I represent Motion Recruitment. We are JobSpring and WorkRage. We're the proud creators of Tech in Motion. Our goal is to create unique experiences for you as candidates and clients, and to do anything from explaining to you what's going on in New York City or any of the 13 places we do business, to helping you with some advice on your job search. We want to talk to you, whether or not you're active on the market or not. Let's get to know you, figure out what makes sense for you, and let's keep in contact over time. Most of our business is repeat, so we appreciate referrals, and a lot of it comes from the folks in this room, so I can't thank you enough. We founded Tech in Motion about 7 years ago now. It started in 2 conference rooms, one in New York City, here in my office, and one in Chicago. There's lots of pizza, lots of engineering talk, lots of late nights. And over time, it's grown into this. And as someone who's seen it from the beginning, I can't say how much we appreciate your support. We really do try to make a difference and give back to the community in unique ways. So every single one of you sitting here is a representation of that today. So I appreciate you. I am going to leave you now. Without further ado, I'm going to hand it off to Chris from Philosophie, who is our co-sponsor for tonight. Thank you.
All right, thank you.
Thank you very much. Yeah, so I'm Chris Butler. I'm Director of AI at Philosophie, and I realize that that's maybe a double-edged title in this room. So really quickly, I think I'd love for our speakers to introduce themselves first, and maybe we start that way and we can go this direction. So Stefan, if you want to start.
That's perfect. Hi, I'm Stefan. I'm from Germany originally. Today I lead a consulting firm in the data science and AI space. We work with a bunch of companies, large and small, to help them figure out, given what their business objectives are, how they can use machine learning and the like to create some values and help them translate that into actual working solutions for the teams and whatnot. That's what I do now. I used to do other stuff before. We can talk about that after.
He's lived in a lot of places as well, so.
Ask him about Brazil. That's what I heard. Hi everyone, I'm Stefana Muller. I work at a startup called Upsani. We're a software startup in early stage, and we're applying AI to the management of applications in cloud production and figuring out how to make them perform really well at low cost using the machine learning aspect of AI.
Hey folks, my name is Sam McKelvey, and I work for a company called Loris AI that's actually a spin out of a nonprofit. So we were born of an organization called Crisis Text Line, And over the years, Crisis Text Line has amassed a huge data corpus of over 70 million messages, all sentiment, labeled on both sides. And they've trained about 14,000 regular people to be crisis counselors. So they are very good at two things, which one is using machine learning and natural language processing to understand what really helps in de-escalating conversations. And two is training regular folks on the basic principles of empathetic communication and pulling in some of the insights from those algorithms. So our founder always said, if you want to make money for your nonprofit, don't sell t-shirts, sell the thing that you're really good at. So that's exactly what we're doing. So at Loris, we're starting with customer service, because you'd be very surprised how similar customer service conversations are to crisis conversations. And we're doing those two things. We're using AI to help companies identify the most positive, or the communication components of their most positive conversations, and then training their customer service agents on those core tenets of empathy, including what we find from the data science. So I'll probably reference both companies throughout the night, trying not to confuse you too much, but Loris is pretty early stage, so a lot of the experience will come from the Crisis Text Line side.
That's great. And yeah, like I said, I'm Chris Butler. I'm from Philosophie, and Philosophie is a design consultancy. And so we do a lot of really early stage design, prototyping, and research. And my role in particular is to help people understand how do we include things like artificial intelligence, machine learning, data science, that type of stuff, into these prototypes. And so that's usually for large enterprises. So we work with companies like Royal Caribbean, PwC, Prudential, but also with very small companies that are just trying to get off the ground. And so I think what's very interesting to me, and I think it's going to be really interesting about talking here, is really what are the real world applications of these technologies, rather than talking about these very lofty ideas and maybe where when we really get into the rut of how movies portray these things. And it's not exactly the way that actually the boring way, and sometimes, that these things are actually implemented or used today, right? So one of the things, we just threw around a bunch of terms like machine learning, AI. I don't know if anybody said deep learning yet, but I just wanted to get a check. Like, do people, raise your hand if you know the difference between those three terms, AI, machine learning, and deep learning.
Oh, good job.
All right, good. So about a third of the group. And then I wanted to get a check on the type of people that were here. So how many people here are engineers, for example? Okay. Data scientists or people that are machine learning or AI experts? Okay, great. What about product people? People that you need the most on your team? Okay, yeah, great. Just kidding. What about designers? Okay, and students, or, yep, and then last but not least is executives and managers. Okay. But what I'd like to start with is why don't we start with talking maybe from your standpoint, what is the definition of, or maybe the main distinctions of, say, like, let's start with you. We'll do AI, machine learning, and deep learning, if that's okay. Is that all right?
I don't know, we were have to answer these questions.
Yeah, no one told us that, by the way.
I would say that AI is when a machine can do tasks that are characteristic of human intelligence.
Great.
Very broad.
Yeah, very broad.
It's a broad definition, but when you get into machine learning, you're more telling the machine how to learn. You're feeding data into it so that it can react properly. It is an algorithm. It's not something special, to be honest.
Just
I
math.
always call it dumb math, right? It's just dumb math, but in the end, the dumb math is actually producing really tangible results based on the great data that you feed it. So that's where I think machine learning comes in, and depending on the type of machine learning you're using, you might get good results.
Yeah, deep learning is just more of the same. So deep learning really is a subfield of machine learning, right? So the idea that you have an algorithm that optimizes some function to figure out some order in the data and use that, what it learns from the data, to predict stuff. Deep learning does that in a very deep sense. So you have very complex models that can find very complex types of orders, like patterns in images or in language and so forth.
I think deep learning has lots of data, I've been told. You're not doing deep learning unless you have lots of data. By the way, I don't agree with that.
All right. Yeah, and I want to throw another term in there too, is data science, and I think I reference the CTO of Data Camp a lot, and kind of the short explanation of this, which is, data science is really for getting insights, and then machine learning is about getting prediction or something like that, and then AI is really about making decisions, right? And so I think these are all great ways to think about that, and that maybe speaks to the point that in some ways these terms are really overloaded today, especially AI. I mean, you did a very good job answering that, because that, like, when we talk about what is actually human cognition in that case too, or what is like human-like, or what is an intelligence, we keep moving the goalposts all the time, right? And so that's maybe the other aspect, is that AI has been around since 1950 if we talk about the actual concept of it. And so yeah, I mean, maybe getting down to what I think is more important, and I'd love to get everybody's thoughts, and maybe starting with Stefan this time. What do you think is the biggest misunderstanding about these terms, or the biggest misunderstanding about the application of these technologies today?
Yeah, with starting with artificial intelligence, maybe it's the idea that it's actually not artificial, which people start to think if you look Westworld, and that it is actually intelligent. So
I thought we were going to wait for them to ask about Westworld.
Oops. But yeah, so generally I guess misunderstanding is that these things start to think and act for themselves, autonomously, set their own goals, and just take action in the real world. They're highly specialized models that are tailored to solve specific problems, and they can only sort of think in the dimensions of the data that you present them, right? And based on those dimensions, they can make decisions that also refer to the objective that typically a human being posed, right? So that's kind of the little box within these things. Do amazing stuff, still amazing, but it's in a box, essentially.
So I think one of the things that a lot of people think about when they think about AI, and it's very different from what you said, because I was trying not to answer that, because that's everyone, right? But a lot of people in my industry think about the fact that AI is going to take over human work. And I hate to bring that up, but I'm bringing it up because we said not to. But I think that the interesting
I'm just going to throw this whole script out the door.
Well, I'm pointing it out because of the fact that a lot of the work that I'm doing today is managing the data center, which humans used to be sitting in this data center all day long, right? And watching things on screens. And guess what? They don't do that anymore. And if you do, I'm sorry, but that's not the way automation works, right? We went from a period of no automation to all human interaction to automation, and now we're automating the automation with learning, right? And letting the machines learn. So in that sense, I think it's an evolution of the technology, and humans have evolved as well. So I think that's one thing that we should keep in mind, is that throughout that evolution, we've all evolved, so we will continue.
So like the Techium, like from Kevin Kelly or something like that.
Sure.
Right. Your turn.
I think the most common misperception, I think there's a couple. I think one is that I think people misperceive how just prevalent AI is in our lives every second of all the time now, and we think of it as chatbots only. We didn't do ourselves any favor by like putting that robot on the event flyer for this thing, but we were talking about how like the spam filter is AI, and how like how we listen to music is AI, how we shop is AI, how we date a lot of the times is AI now. So it's really pervasive in our lives more than just the chatbots or the robots that we think about. And then the other big misconception, I think, is that even though it's so pervasive, I feel like people feel like we're so much further than we actually are. Like, AI can barely schedule meetings without a human helping right now still. And like, if you've ever tried to use Alexa with someone over 70, that's the best thing.
It's actually hilarious.
It's amazing.
Is it because they're too polite? Is that the problem?
They just don't like get it, and they, we think AI is going to take over the world, but you have to like say the perfect thing to get it to do something. I was at a dinner once, with an Italian dinner with these friends, and they kept being like, play Puccini arias, and then like you have to say Alexa. You have to say Alexa. They're like, Alexa, play arias by Puccini, and like nothing would happen. Is she doing it?
She is.
If she started
She's right here.
If she started playing arias, that would totally defeat my story. But we still have a long ways to go in the recognition, especially in voice and language. So that's what I think the biggest misperception is.
Yeah, I agree. I mean, definitely in the practice that we do a lot of the time is trying to pull people back from some type of understanding that it's just like magic dust that you spread over a product and then suddenly everything's perfect. But I think also the misunderstanding is that it does have to just be certain types of like embodiments, like a chatbot, right? I mean, the idea of using prediction services is something that people have been doing for a very long time, just not using machine learning, not using deep learning. And so being able to integrate those types of services, I think, is really helpful, but it means that it doesn't always look like AI, right, or machine learning. It's not a white plastic robot with a human face on it and a big blue, like, glowing brain behind it necessarily. So, so I mean, I think what I would really love to talk about next is, now that we're in the trough of disillusionment for this particular set of technologies, what are good examples that you have seen for particular particular implementations of these things? And you can definitely use more generic ones, but I'd love to hear from you in particular, like where you've used these things. And so, go this first.
Yeah. So at Loris, we use AI in 3 ways particularly. One is, like I said, to use the natural language processing and sentiment analysis of how customers are reacting to understand the components of a conversation that's rated positive in sentiment analysis, or what's going on within a conversation that's rated positive with a NPS score or CSAT survey or customer satisfaction survey. That's one way. The second way is more traditional. We do have people as part of the training interact with a customer bot. So you interact with our customer bot, and if you, for example, ask questions that start with the word why, we know that does not evoke positive sentiment in people. It makes people feel judged, so the bot will get very annoyed with you. If you use maximizers and minimizers like so and very and just and really, the bot will also get a little annoyed with you. And then the last way is we really want a scalable way to assess how people are performing. So we're teaching people empathy skills, and we want to make sure that they're actually implementing those skills. So we could do that by administering quizzes, which we do a little bit, but that's really going to test for memorization. We could look at those NPS scores, those Net Promoter Scores, and those customer satisfaction scores, but those could be tied to a million other outcomes besides just the empathy that a customer service agent might be demonstrating. So what we really want to do is, and what we're developing right now, is what we call an empathy score, where we can go through and algorithmically score conversations and report back in real time what a person's empathy score, what a department's empathy score is, and where they need to improve. So that whole scalability side of it is something that I think is really important when you're thinking about where and when to incorporate machine learning.
Yeah, I guess how do you turn something like empathy into a score? I mean, that seems like a very difficult thing to do.
I mean, it is.
Well, can you tell us how?
Yeah, I mean, I think that is one of the challenges of AI and machine learning. Is it's expensive both in terms of actual money, in terms of time, in terms of people. So what we measure are things like, do you say, give someone like a strength identification, what we'd call like telling them something positive about themselves every 10 minutes? Do you not ask questions that start with the word why? Do you ask questions that start with how, when, things like that? Do you ask open-ended questions? Do you avoid those maximizers? Do you paraphrase without mirroring? And teaching machines to do that is also really hard. And I think, there is a bit of a myth and misconception that is coming out more and more now that you write an algorithm and then you figured it out. Like, you have humans score all this first. Like, we have people going through and checking the algorithm alongside, alongside the algorithm. So there does need to be, when you're developing this, a human in the loop, absolutely. So it's a big investment, but it's going to pay off long term in terms of scalability.
So repeat the question.
Yeah.
So, what are some good examples in real life that you've used? Yeah.
So what we do at Upsani, we take AI and we apply it to applications running in the cloud, which is practically almost every application nowadays, right? Almost everything is running as a SaaS service. Even if you log into your bank, it is a SaaS service. It's not just a website anymore. The interesting thing about that is there's a ton of humans managing that in the background. And for example, one of my beta testers has 4,000 applications to manage and 7 people. Do you see a scale problem, anyone? So the interesting thing about it is they were talking to us about this challenge that they had. They had 7 SREs, 4,000 applications. 25% of those are really important applications for their business. So we decided that we were going to try to use machine learning to determine the best possible outcome for their application in performance. What settings to set for CPU for each container. So guys, anyone microservices centered here? Okay, so we've got one person who understands that, great. No. But if you're thinking about it, how an application runs, it's not just one server anymore, right? It's a bunch of little containers that are running your application and they're all connected. The funny thing is that humans still have to run tell the container how to run. Container, run with this much memory. Container, run with this much CPU. Container, run with this setting of garbage collection or thread count, or run on this VM in AWS. There are thousands of settings. Again, a human doesn't have the time to go through thousands of settings. So we applied a machine learning algorithm to that, and we have a neural net that actually learns along the way. And when we did it in first test, and we're early stage, so we were testing it out with a few companies, we threw the algorithm against, or the neural net against this system. It was a video conferencing system. Think of, you guys use video conference, WebEx, Zoom, there's a bunch of different systems like that. But video conferencing has to be up and running or everyone is pissed off. Who works and does video conferencing, ever? Everyone, that's the answer. Anyone FaceTime? Okay, that's a video conferencing service. So I guess the thing is, if it goes down or if even there's a blip, it's a big problem. So performance is key. We apply the algorithm to it and we learn over time. So it's not a smart algorithm. It's just gonna learn what your performance metric is and it's gonna measure it, change a few things, measure it again, change a few things, measure it again, and it learns. And initially, it does some really crazy things, like it goes out like a spider and figures out which ones to touch, and then it hones in and gets very specific. The interesting thing to us was that we didn't know how the neural net would react, and it did some things we never thought it would do. So we're trying to figure out how it knew to do that. So we'll figure that out one day. That's where the craziness comes, right? I know this is only managing machines, but it's kind of scary that we didn't know, humans didn't realize to do those things. In the end, we got some really great results. So the beta customers have seen like 25% to 35% reduction in cost on their cloud spend. And anyone who's a CFO in the room is going to like almost pass out from that, because I had to answer the CFO a few times and I know how difficult that is to reduce cloud spend. And then the second thing was performance. It's just increasing performance by almost 200% without changing the cost of running that application. So big companies who are spending $100,000 a month on cloud spend are going to be looking at that type of technology. And good thing is it's the first time anything has been proven, so we're excited about it. I know I kind of give you a pitch for my product, but that's not what I do. I just wanted to share that it was a really cool technology. We didn't think it would work.
Seemed very natural.
And
it
did. No, it did work. And the cool thing is we didn't even understand how it works, and we had to work and reverse engineer our algorithm to figure out how it worked, how the machine learning figured it out.
Well, that's great. Well, I want to get to explainability and interpretability. And
Yeah.
that's
Okay. So I went off script
No, you
again.
did not.
I did.
You did not.
Sorry.
It's okay. So yeah, please.
Yeah, cool. So we work with a range of different companies, and so most of the surveys, they always say that most of the value will be generated in marketing around personalization and predictive maintenance, like anomaly detection and the likes, and then sort of supply chain management around prediction where shortages are. So I see most of the activity going on around marketing. So I have quite a few clients that use it for, say, simply better targeting customers, right? And that really shows you how machine learning works. You have maybe a few 100 million interactions with customers or prior campaigns, and you can combine this with tens of thousands of variables that you have from whatever source, right? Be that the sensors, be that internal data. And the algorithm essentially is just able to kind of leverage that information and exploit it much more efficiently than a human ever could in his lifetime or her lifetime, right? So that's essentially where you get, and the nice thing about providing such services is that you can measure the value quite easily, right? You know, okay, so your response rate maybe goes from 1% to 1.5%, it's measurable, so everybody's happy, right? So that stuff works really well, but it is actually not that super exciting. Because really, if you ever ran a linear regression at some point, it's the same plus plus, right? It's really just more complex models. Then what I actually enjoy doing a lot is working with natural language data, because if you think about it, most of sort of the human knowledge and these things are actually embedded in speech, right? Because we think, we talk, and so forth, and language. So if you actually manage to kind of extract that stuff, it gets very powerful. So one useful application is, for instance, to work with a law firm that wants to streamline document review, right? Because lawyers, especially at the beginning, is not necessarily the most glamorous job because you spend quite a bit of time just reviewing documents, right? So this can be done much more efficiently in terms of figuring out which topics are being discussed and specific things that matter, and computerizing this and learning over time, right? And of course, you have this interaction where you start with some unsupervised algorithm where you kind of start to build some structure, you get feedback from humans, is that the right way to represent that body of documents, and so forth, right? But then you bring very tangible sort of savings in terms of not only time, but also pain, right? Because it's not the most pleasant thing to do, so.
Yeah, and so everybody's been talking a little bit about automation in general, but how do we make the decision, or how do you find the right place that humans should be taking action and taking control, right? And machines should be taking control. Where's that middle ground, I guess? Who wants this? Yeah.
So in my example, it's very simple because we're not dealing with humans in the end. So that's good news. We're not really affecting humans. Well, maybe. We might affect your performance when you go to a website and it's not loading in like 0.1 seconds.
You're saying that there's a time that a human is out of the loop for
There
these
is.
types of things? I don't know if I agree.
My
with that,
algorithm
but-
works by itself. Oh, I think the interesting thing though is that we learn from the algorithm and we end up learning. So when you're configuring servers, there's an art to that. It is not a science anymore because every configuration is different depending on the type of user, the type of usage, whatnot. For some reason, it's not a science. We're trying to bring it back to be a science. It used to be, right? 20 years ago when I was doing this. So the interesting thing I think about it is the art is in blogs. People blog about, oh, this is the change you should make to Nginx to make it work well. Or if you're running a Postgres server, run it this way, right? There's a lot of data out there that can teach our algorithm upfront. So that's what we're feeding in upfront. We actually call that heuristics, but in the end, it's just our people writing the right rules to try this first. So we're directing the neural net in the right direction. I think it's important to set those barriers around the neural net so that we don't make stupid mistakes, because the algorithm is kind of dumb. We talked about this earlier, but the algorithm's dumb. It's doing what I tell it to do, exactly what I tell it to do.
I think that, I mean, humans are best sort of brought in when there's a certain degree of risk involved and then there's a certain degree of nuance involved. So a very specific example from the crisis text line side of things, they use algorithms to prioritize their crisis queue. They do that because humans were pretty bad at prioritizing the crisis queue. So understanding when people first text in to receive crisis help, they'll get like an automated message. They know it's automated. We're going to connect you with someone to soon. Tell us a little bit about what's going on today. And then from the message that that person sends back, being able to determine sort of what is the level of urgency based on really the risk of suicide. When we first started working on this, we thought that you should prioritize words like suicide or kill or die. But what we learned over time was words like CVS were much more indicative of risk. The sad face emoji was much more indicative of suicidal risk. The name of any prescription drug whatsoever was much more indicative of suicidal risk. So we use an algorithm to that point, but we know that the nuance of conversation is still best left to a human. So I think when we are dealing with language and subtleties, especially in very high risk situations, that's when we want to bring in the human element to really handle those conversations. And it's really similar on the Loris side of customer service as well. I mean, we do not mind talking to a bot at all to solve really simple customer service problems. But like, if we're pissed and there's like a million things on our mind and a million directions that things could go, like, we want to talk to a human and we want to get it taken care of. So if there's emotion involved, if there's nuance involved, that's really best handled by a human.
And I wonder if it's about like that mirroring that's really important too,
Yeah.
right? That's really interesting. Yeah.
Yeah, as a matter of fact, humans are involved throughout the life cycle of any application anyway. So I think McKinsey did a survey and asked like 1,000 company representatives, and they come up with like 600 different use cases, which means it's highly customized, and you have to figure out in your specific situation how you can use these sort of generic technologies, right? So you have to find ways where you have the data and the objectives, where kind of the technology can bridge between the two. So you have to do that, then you have to decide that you want to try it, then you have to research and design the whole thing, and then ultimately it's supposed to perform according to some specs, right? So you're going to have some metrics, and then it's going to work and maybe be in production and automate something, and then it's got to keep working according to those specs. So you got to keep monitoring it, right? Things change, and so you're going to be involved at some level, and depending on the complexity of the system, there may be more touch points along the way where you monitor more things and have to correct more often, right? But it's always this box that does stuff that may be custom and tough or challenging to build, at least because it's a new thing that will change over time. But basically humans will be supervising the whole thing from the outside, beginning to end, and again and again.
Yeah, and I mean, when we talk about the idea of outcomes, or how you're, in the case of, say, a machine learning algorithm, how are you optimizing something, it does seem an awful lot like the times that humans are most necessary are when it's not very easy to define that outcome, right? And so it ends up being one of those things where there's so much context that's required, there's so much history, maybe cultural understanding, or even just the idea of being able to connect with another human being in that context. And so it becomes really tricky, because I guess it can really pass over that threshold very quickly in some cases, even for very simple things. I think one of the research aspects that we think about a lot is how do you start to understand what people expect or interpret from an interface. And there's a lot of interesting ways that you can use kind of the two sides of the coin of, say, like, are people familiar with like MVP terminology like concierge or Wizard of Oz? Well, if not, concierge is basically that it seems like you're talking to a human the whole time, and they're really trying to be as custom to what your needs are at that moment. But it could be a machine, or it could be a human that's heavily assisted by a machine. And the reverse is Wizard of Oz, where it looks like it's maybe a machine, but there's really a human in the background kind of pulling the levers. And so, there's different ways that you can think about this, and if there's an expectation that a system will just take care of the job, you start from the standpoint of an MVP of a Wizard of Oz. But until you can actually build the intelligence, until you can collect the data and actually clean it, maybe that's something that you can do to start to understand the way these issues really matter and where the context matters. And so maybe this is a good segue. I mean, trust seems to be one of those things that's really difficult for humans to build between each other. We do have cultural norms that help with trust. It means that we're more easily able to transact with each other in some ways, within organizations, within countries, and just day-to-day life. But how does trust come into this equation when talking about automation and how people actually interact with these systems? And so, why don't we start with this?
Yeah, so again, so my perspective is often dealing with decision makers who have to be comfortable with either going for the journey of implementing some sort of system, or then once you show them how it works, to kind of really go for embedding this in the workflow. So there have been great advances, I think, actually in the last 6-12 months in terms of making the operations and the inner workings of models more transparent. That is a major breakthrough, because now you can actually show that this supposed black box is actually not that black, right? It's sort of semi-gray. If you were willing to spend a lot of time, you could dive into and actually take the whole thing apart. That's going to take a long time because there's a lot of numbers to look at, but you can get high-level sort of visualizations of what's actually going on. So in that sense, and if you then can also see that the things that matter for the model's operations is kind of what you would expect. So there's some plausible story behind the drives of the model. That's extremely
Is that explainability or rationalization?
I guess first of all, you have to be able to kind of aggregate or have some explanation generally what's going on that's humanly understandable, right? And then that has to be sort of in sync with what you are thinking with your mental model that you have, right? Look at investment, right? So you do algorithmic trading and you try to build machine learning algorithms to kind of come up with some signal. If you cannot really come up with some economic story why whatever you're coming up with makes sense, people just will not put their money on this, right? Because it could just be a random occurrence of the data and tomorrow it's gone and so is my money, so hence.
What about the illusion of control and like thermostats in offices, for example, or closed door buttons, right? Like the idea that those things don't work, but they give us comfort. And so, I don't know, it's something I wonder about long term. We'll go next. Yeah. No, we'll go.
I don't really have a lot to add because I think transparency is the most important component of trust. I think it gets really complex with deep learning. I think the second thing is just exposure to this technology, and I think that a lot of that kind of falls on us in this community to talk more to folks who aren't in the tech community about the way this impacts and touches our lives all the time. So obviously in B2B applications, it really is, building trust in the algorithm, but in more B2C adoption, I think it really does fall upon us in this community to kind of do more work to bring AI to the forefront and let folks outside of the tech community know just how prevalent it already is in their lives and how impactful it is in a good way in their lives already.
The headlines don't help, I think. Interesting.
Which headlines are you thinking
All
about?
of them.
Yeah.
So by the way, the headlines are generated by AI. If anyone was wondering, it is. Actually, Associated Press generates the majority of their articles through AI. Yeah, stop reading. No, I'm using that as an example. One of the things that I found to get people more open to using AI in things that they need to work, right? I cannot ask them to throw this in production, right? It's not going to work the first time. It takes a lot of trial. So I say it's trial and trial and trial and proving. You have to prove out your algorithm. You have to prove that the neural net can work in various scenarios, just like you do in quality testing. And then the build of trust happens. Very similar to how human trust happens. You have to prove yourself. You have to build that relationship. I think that the same thing with using a new tool that seems to run on its own. Visibility helps, but in my world, visibility takes a lot of time to see how that happened. So I think it's the trial that helps, and don't read the headlines, that's it.
Yeah, I mean, it definitely is very interesting. I wonder when you talk about transparency as well, right? What does that mean in your case?
So in our case, the transparency is we can show you the result of what the algorithm found, and we can not implement it. You can choose to implement that result, maybe.
Yeah, I mean, I guess I do worry that with the adoption of, say, agile in organizations or agile thinking, of iterative thinking, we have things like SAFe now, right? Which, are people familiar with SAFe? Is anybody a SAFe practitioner in here?
It used to be.
It's capital S, capital A, capital F, lowercase e, and it's basically waterfall or gated methodology that looks like agile. So you can say you're doing it. I'm sorry to anybody that is.
Nobody can push anything to production until 20 people approve it. Same thing that we did 20 years ago, guys. If you're all here, like me,
exactly.
That's what SAFe is.
Well, that's what worries me about this, is that because there is so much iteration and learning, and my favorite quote is from Alan Turing, right, who said that, for something to be truly intelligent, it will be fallible. And I'm, of course, butchering that term, but that phrase. But, I mean, that's the truth, is these things will make mistakes. And so how do we start to build, and maybe this is the last question before I think we open up to questions, but how do we build that with executives, this understanding that things are not perfect, right, especially in these types of services?
Well, current services are not perfect. Their error rate is
but those
high.
bugs were not expected.
Think about it. How many car deaths do we have every day? and then one autonomous car gets in an accident and everyone's in an uproar, right? Hey, that was one out of how many? Look at the statistics. We need to look at data and prove it with data. We can't just prove it with headlines, right? Or sensationalism. I'm using headlines as an example of sensationalism, but that's what it is. And I think executives are smarter than that, but unfortunately in some cases when they're not tech executives and they're not used to this innovative mindset, or they have regulation to deal with, right? Maybe they want to be innovative, but they can't. That's where we have to prove it. We have to show information that proves that this is more accurate than the human involvement that was originally, or the slow process that was originally. So yeah, that's my general statement there.
Yeah, so it clearly takes a lot of individual work in terms of convincing people. It's education, really, right? I mean, it does help that there is a general push that people feel like they have to do something in this space. So there's more willingness to experiment, and there's some budget, and then you work, right? It's a day after day kind of explanation of how this works, what you should expect, and precisely just dealing with this uncertainty that things will have this margin of error, and sometimes it works, and sometimes it doesn't, is a sort of part of the puzzle. And I think this is kind of the habit that people will develop over time, that this is just how these things work, and of course they will also get better, but we gotta kind of be there every day. I did a lot of teaching, and I'm still doing it in this context.
So it does take a lot of humans, you mean?
Exactly.
See, I told you.
What do you think, Sam?
I'm gonna end on a positive note. I mean, from the
We have a few more minutes. We can do another question. So you can go negative now if you want to.
The companies that I talk to about adopting Loris literally have no idea what's going on in their customer service conversations. So when you say, I can use an algorithm to show you what works, they're like, holy shit, that's amazing. And I think that is really a key component. If you can, like Stefano was saying, if you can demonstrate that we can do things better, if you can give executives insights out of the gate and tell them something they didn't know before, or demonstrate how you're going to be able to do that, I think that's really key.
Yeah, I mean, the whole performance thing is really interesting. I guess I liken it to a story when I was at Waze and we were launching a lot of the ad products, and the best alternative at that point was really billboards. And physical billboards, don't have really great tracking capabilities. And so, we started to actually implement these things where you could track whether something was redeemed by driving there. People are like, oh, this is awesome, I love this data, but why are the rates so low, right? And the truth is because the other way, the billboard way, even though it was not tracked, probably sucked even more than the way we were doing it initially, right? And when we talk about a lot of these machine learning metrics, especially things like performance, right? The idea of overall accuracy could be 52%. That's still a lot better than whatever you had previously. And I think that's maybe the issue about whether tracking of these types of things, of say human functions, they used to be human functions, and how we track those things in a way that is maybe still humane, but does show that machines can be better at certain things. Okay, well, so maybe let's look forward to the future, maybe in a more positive light. But how do you see the practice of building machine learning models, training them, integrating things like artificially intelligent systems, things like that? How do you see that evolving over time? And maybe let's set a horizon of like the next 3 years, right? How do you see that changing? It could really be anything that you think of. And you go ahead and start, Sam.
Yeah, I mean, my sort of vision for the future of this, and I feel like I'm harping on this a lot, is just the exposure and the willingness to adopt in the community outside the tech community. So I think that there is a tension between the ease that AI and machine learning brings to our life and our jobs, and what people perceive as misinformation. So AI creating headlines, AI doing things in the election, and allegedly, and getting a bad rap generally. But I mean, I think that my hope in practice is that people will able to see just all the ways in which in which it does impact their lives and adopt a willingness to sort of be able to incorporate it more fully.
So I think that it's similar to your answer, but it's more the transparency of how AI makes the decisions it makes. There's been a few studies that at MIT, at Google, that have found a way to track how not just machine learning, but even deep learning made the decision, how it can calculate that decision. And maybe it could teach us how to think differently as humans. So we have consciousness, we have instinct. Machines don't have that, but maybe the machines have something else, right? And I think that's pretty cool and something that we can learn from. So every time my algorithm, or I'll call it my AI, right? We should get a name for it, him, or her. We won't get on there. So we should have a name for it, but in the end, when it finds something that I never thought to think about, I always want to track it back, and we try to, and sometimes we can't yet because it's too smart for us, right? Or it made too many calculations for our machines to figure out. But I think in the next 3 years, we're going to have more visibility like that, and that might build more trust. And I think that's where we're headed. So we will be more cognizant of when AI is being used or at play, and less worried.
Yeah, and so similar to the earlier point that there are so many different areas where you can apply it and it works, right? People will do this more and more, so you will see more expertise throughout, again, looking more at the companies and the consumer side, so you will see much more expertise in companies where it can be applied, what are the prerequisites, what should I expect in terms of how long it takes, you know, for a model to be up and running, and what should I expect in terms of performance improvement. So people will be asking for this, right? There's so many people studying, some taking courses, learning, right? I mean, it's pretty massive. So I do think that this will be just completely demystified, not completely, but to a large extent demystified, right? So it will be another tool in your box to kind of drive some value, and people will generally understand the principles and start spotting, oh, this is an opportunity where I can probably do something, and it's probably going to work, and then I'm going to either have people already in 3 years who can do this, or there's going to be an API for that, or I just call it a consultant.
Yeah, I mean, I think, I definitely think that, I mean, I guess my prediction for the next 3 years is really that the hype is just going to burn out. And that, just like I had a title a couple years ago that included mobile in it, my title of Director of AI right now is going to sound as antiquated as that. And I think it's the same thing when we talk about like tech evangelism back in the day, when we talk about the way web services now is just standard and there's frameworks for it. I mean, I think there's a lot of fervor around it right now, but making it more of a component of how we actually build services with everything else in our toolbox, I think that's, for it to survive, like for it to actually matter, we need to be able to do like the regular stuff that we do as like product people, designers, and engineers. I guess that's fine. So why don't we, first of all, give a round of applause for everybody up here. And then, yeah, we'd like to start taking questions from the audience.
Don't ask about the camera that's scanning your faces.
I will walk around with the microphone right out front. He's the expert.
Thank you, guys. This is a really good panel, and my question is for Sam. I think it's super interesting when you are launching a company that you have a North Star metric that you can embed and convince customers with, that this is the value proposition that we bring, because we've got some secret sauce towards empathy. And we tried doing that with performance. We said scalability, latency, concurrency, accuracy. We came up with that, and we came up with a rule-based, best-in-class performance standard. My question to you is, more so than defining what empathy means, which could be sensitivity, NPS, how do you convince customers that it actually truly matters beyond white papers and everything else?
So we have a few things on our side with this right now. One is companies like Amazon just ruling supreme, and the reason one of the reasons doing that is because they are, quote, obsessed with the customer. So pointing to the fact that being obsessed with your customer is something that is definitely in our corner right now. Empathy is also just a big buzzword in business right now. So luckily at Crisis Text Line, that was already part of the lexicon that we use all the time to describe our crisis counselors, our empathy MVPs. So it's been actually quite easy to talk to business leaders using that terminology, but I bet if we talk in 3 years, it'll be called something else. Because I already believe that sort of what we're teaching, the mix of communication skills that build connections along with using data to understand what makes people feel good about your brand in a I one of the things we're very conscious of is like, we're not those icky people that do like empathy marketing that try to just like sell you stuff by understanding like who you are, like how Instagram just every day is like, Sam, do you want to freeze your eggs? And I'm like, no, I know you know I'm old and single. Like, stop reminding me. But that's not what we're doing. We really, we really do. I mean, this is a social enterprise, and we want to bring more empathy to the world. But I feel like we're onto something bigger. So for us, the choice of the word empathy has been really understanding product market fit and what companies are looking for right now. We interviewed about 50 companies in January and February. That's all we did was did a lot of PR, like if you want to be part of our beta, like talk to us about empathy and authenticity and hard conversations at your company. And we've gone a million different directions from there. We started with hard conversations, and so it really was understanding our audience and our customer.
Next, over here.
Hello. My question is for Sam again. How do you improve accuracy with sentiment analysis, and also with all these user data privacy laws changing, with Facebook starting the whole chain? Do you think it's a way of the future to understand how people of a large area or group would react to certain events going on?
Can you repeat the second part of the question?
Sure. I'm sorry about that.
That's okay.
With
everything going on, data privacy,
with everything with
Facebook.
the user data privacy laws changing, do you think sentiment analysis is a way of the future in understanding how majority of people or select groups would react to a certain situation or a certain statement by someone of importance?
Yeah. I mean, I think that's also very hard to answer. I think that with everything going on, we want to protect our users, we want to protect ourselves. But I do think that we will see more sentiment analysis, yes, to kind of understand how what we're saying is evoking emotion in people. And if folks aren't super familiar with that, it's really quite rudimentary. It's, does this make a person feel positive? Does this make a person feel negative? Does this make a person feel neutral? So if I say, I love the Golden Girls, then that's a very easy, like, makes me feel positive. But if I say, I love the Golden Girls, but I wouldn't recommend it to everyone, then that becomes, like, much more difficult. So there's still ways to go with sentiment analysis, but I do think it is going to be paramount in understanding, like, how people are reacting with privacy laws.
Yeah, just to add to that briefly, so in terms of natural language understanding, right, to the second part of your question, well, you may have heard Zuckerberg's statements in the Senate. He deliberately said that kind of technique, there will be like 5 years or more away, right? So in terms of developing a nuanced understanding of what is being said and how that could be sort of perceived, that's going to take quite a bit of time, right? I mean, the Alexa prize is underway. You know, the prize that Amazon kind of, you know, basically doles out to millions, similar to what DARPA did with the self-driving cars. The goal is to have like a 20-minute conversation that is like rated 4 out of 5, right? So that is still relatively basic stuff. Now, in 10, 20 years, will look very different.
Yeah, it's interesting, especially to think about the differences and kind of, it feels like image analysis, for example, is ahead of things like NLP, and I do wonder if that's because imagery or the idea of like visual identification is so rudimentary, whereas things like sentiment or other types of textual analysis have so much to do with this crazy thing we created, which is language, right? And how to communicate ideas. I do wonder how that changes over time. Yeah. Do you want to say that? All right. What's the next question?
Hi. So I think one of the drivers for AI is that businesses continuously want to have a way for repeatable, better business decisions. And if you look at AI and ML as a technique, that's kind of what it does. It's figure out a better way to have a repeatable decision. But in order to implement this, you need a lot of extremely experienced people, which don't exist today. So basically, there is a really big talent gap.
I mean, I guess the way that I interpret this question, I'd love to hear the way everybody else does too, but you know, there is an issue that people that are experts, as they use these systems, become less expert, right? And that is a real issue when we talk about this.
I'm referring to the actual development. So you have a business and they allocate money,
sure.
And then you need somebody like all these 3 guys or 4 guys here that eventually actually takes a business need, create a product or service.
But that, you know, but that's just like, I think that's, to me, that's the progression of the industry, because like, you know, for a long time, you had to like write Perl to be able to create websites, right? And you had to do like CGI bin, you had to do all these horrible, horrible things.
I never did that.
Yeah, to create websites, right?
No.
It was horrible, okay, is all I'm saying. And so I just think like, as these tools, you know, as people that are doing things like Keras, as people are starting to do things like machine learning as a service, like all these different things are trying to make it so that it is easier and more understandable. So it comes out of kind of the research realm, which is really where it is for a lot of these things, right? There still is so much research to do, but I just think like for a lot of these basic tools, I think you're going to see more kind of like, it's going to be easier to use as time goes on.
I mean, I think that the tools have started touching the market, right? We see it every day in my Spotify list. It's terrible, by the way. I can't figure out what kind of music I like on my daily feed. But in any case, you know, the research is starting to touch the market. But I also think to talk about that job discussion, because that was something I started with in this discussion, and I was off topic, but the point I was making is that as technology evolves, we evolve, right? We're not writing Perl anymore, or if you are, I'm sorry, but I've never done that. That was sarcasm, but I think the big difference is that as we evolve technology, people evolve skills, and we learn new things. There are going to be interfaces to AI in the future that you don't have to be a big data engineer or a data scientist or a machine learning expert to employ the tool. And I think that's what that evolution is happening now. I've seen it in the market today and will continue to see it, but you're right, there is a skills gap, as is with any new technology. You know, 4 years ago, DevOps people were like in demand. They're still in demand, but nobody can tell me what a DevOps person is, right? And that was my industry back then. So I think it happens in every industry with every new technology. That wave will come in, and I'll give this out there. I'm hiring in California. Okay, so I'm sorry about that, but I'm hiring in California 1 machine learning engineer. Guess how many applicants I have? 700. I'm employing AI to go through that right now. But I want you to know that there are skills. There are people with those skills. And that's why I have to figure out who out of the 700 really has those skills. But there are people. We just need to find them and put them in the right spots.
Yeah, I also think, so I agree that the gap is fairly large right now, especially if you go out of sort of the urban centers, say New York and so on, where, you know, this knowledge sort of, you know, diffuses a little quicker. Personally, I think in terms of the impact of AI on jobs and the like, the biggest wild card is industry adoption overall, and I think that sort of the lack of understanding, especially at the senior decision maker level, is kind of the biggest block right now. It's not quite clear how fast this is going to progress. I think it's going to change quite a bit over the next 5 years. Maybe it takes 10 years, maybe it happens in 3 years. It will change, right? But right now, yes, it's a good time for people who can fill that gap, for sure.
So jump in.
Yes, speaking to tech in motion and tools, and this is actually to anybody in the audience, I'm looking for a AI or a company or a program wherein you're in a car, you're doing, say, 60 miles an hour, you hit a waypoint, it triggers some TTS, some text-to-speech, and then your next waypoint is upcoming and it's a mile away, so you have 1 minute, and you're doing 60 miles an hour, so you have that much speech there. But if you're doing 75 miles an hour, 80 miles an hour, how do you fit that TTS to go faster? Is there any kind of program or anything of that sort that is out there in a generic way?
I mean, it would depend on the application, right? I mean, Waze definitely has a problem where when there's very, very long names for exits, it spends like 5 minutes reading off every absolute possibility.
Long Island,
yeah.
and Indian names like Massapequa.
Yeah, definitely chewing those up. Yeah, but I guess like this comes down to the fact that it really depends on the use, right? I mean, there's many different ways to actually answer that question. It doesn't always have to be just TTS. There are ways that you could do things like that. But I mean, I think we'd really have to talk about the actual use. But if there's another question, we should probably move on.
Hi, I had a question.
I was just going to ask, like, on an individual basis, like as a engineer using ML, how are you supposed to stay, like, how does one, I just graduated in May, and I feel like over the course of the last semester, like what was considered the best tool for the job in terms of what type of network, for deep learning applications for different sorts of problems, like that changed so much, just like they literally changed the curriculum. It's like changing really fast, and now that I'm out of school and working, I don't want to, like, how do you read a PhD paper a day? Like, what do you do?
Never. I don't read PhD paper. I read the headlines. No. Do you want to take it or? So how do I keep in touch with what's happening? I have to be very specific about my product area, right? So that's easier because I'm being specific about my application. I do look at research. I do talk to people a lot. That keeps me up to date. I'm not reading every research paper. I'm more trying to find things that apply to my business. So it is a lot easier when you hone in on what you're going to apply that technology to or that learning to. So for me, I think it's a lot easier. It's still drinking from a fire hose, TensorFlow and this and that, and I'm learning all about how that works and how it doesn't lately. And next week I'm going to be using a different algorithm. So yes, I hear you, but I also think that when you hone in on an area that you want to target, you can find targeted technology, targeted information, and targeted conversations. That's what I do.
I mean, and you should just be learning to learn, right? Like that's the truth about all of these technologies. I've been working in the industry for like 18 years, right? And so there's been a lot of changes. I think the problem with machine learning frameworks right now is that there does seem to be a lot of churn, right? Like TensorFlow came out and a bunch of people, Google put all of their marketing machine behind that, and so everybody thought, oh, everybody's going to use TensorFlow, but then PyTorch comes along, and in like a year basically changes the entire industry, right? And so I think it's more about, there's definitely things like architecture models, patterns of usage, things like that won't change as much, but learning how to learn those things is really what's most important. And I don't know, that's the skill that I think is always most important when we talk about technology, because things change so rapidly.
So when I'm hiring a machine learning engineer, I'm not looking at, just to give you basics, I need to know that person has done something with their work, right? They can show me an example. They have,
and failed in some way.
A GitHub account or something, and they can show their failure over time. They can show check-ins. They can show that they've tried things a few times. I like to see that because that means you're resilient. So I think those are some of the things that I'm looking for out of every 700 applicants right now, but every applicant I'm looking towards that. It's not that you know every technology, it's that you can hone in on a technology and learn it pretty well to make the mistakes and fix them.
I actually meant like besides from the technology, because that's sort of like, obviously that's part of like being an engineer. I actually meant like, I do think the architectures are changing rapidly, like what's considered the best, like, oh, like we didn't have GANs working a year ago, and now we do, and everyone's losing their mind about it.
And that's very true. I mean, I think the good thing is like Medium, there's lots of people that are trying to explain and reinterpret a lot of the papers that are coming out right now, and so that's where I tend to get most of my information. I do try to read papers. They're not, I fall asleep reading a lot of them, but I mean, it will keep changing. right? It's so early because now we can apply the amount of computing we can to these models that we're going to start discovering new ones, right? So I have compassion for what you're going through. I don't know what to tell you though. At this point.
And this is
Yeah.
kind of a trite answer, but I think community is so important for that. So being a part of a community where you know, you can learn together and stay abreast of those kinds of things is so critical. And then you don't feel like you're swimming alone in this thing that's ever evolving.
Yeah. So another question.
Oh, sorry. Actually, we're
Oh.
out of time.
No.
You can. We're actually gonna wrap
Again-
up there.
I can
We
ask
can
or I
meet
can order?
after. We can ask after. We're all gonna go over to Emmett and Lonnie's, which is like literally downstairs if you guys want to go. But big round of applause to everyone.
Thank you everybody for coming. It was really great. Thank you to all the guests.
Thank you, everyone. Thank you all so much for coming. Sorry to cut you all short. We only have a space to a certain amount of time. Next up will be our July event on July 25th. I'd love to see you all there. It is a big summer mixer to celebrate us hitting 100,000 members across the country. That will be down at the DL in the Lower East Side. We'll see you there. If you would like to continue asking questions, talking to each other, we'll be downstairs at Emmett. Oh, I cannot say it. It's a pub. Emmett O'Lenny's. I literally have the same address as this venue, so it's downstairs within walking distance.
And we'll see you there. Thank
We'll
you for
see you
coming.
there. Thank you all. If you can grab your trash or your bottles or anything and throw those out, that'd be amazing. Thank you guys.
Thank you very much.
Thank you.
You guys are rock stars. Great job.